Hello everyone, my name is Coppieters and I'm from DoCoLab in Ghent. In this poster presentation I will talk about the NANOFLOW LCMS method for the confirmatory analysis of small peptide hormones in doping control. The method employs direct urine injection, which is enabled by the use of an online filter. So in general, when employing nano-LCMS, labor-intensive and time-consuming manual sample cleanup steps are often required. Examples of these are ultrafiltration, immunoaffinity purification, and solid phase extraction. And these are often required to obtain clean sample extracts, which is important when employing NanoFlow LCMS, as this employs narrow tubing and connections in combination with very low flow rates. Of course, it would be more beneficial to eliminate these offline sample preparation steps in order to save both time and costs, especially in a routine environment such as found in doping control laboratories. Thus, in order to alleviate offline sample preparation, we decided to use a direct urine injection methodology, also known as dilute and shoot, as is already often applied in screening methods employing analytical flow rates. So we diluted our urine samples 16-fold, after which we centrifuged them for 5 minutes, and then we injected them straight onto the nano-LCMS system. On this slide you can see the valve configuration of our NanoFlow setup. And as has already been described by others previously and in a variety of applications, we decided to incorporate a 1 micrometer stainless steel filter in the flow path. And this filter essentially prevents particles from entering and clogging the chromatographic system. Chromatographic setup, which is a miniaturized setup in our case, as we're employing NanoFlow. And this essentially improves robustness, which is obviously a challenge often associated with nano LCMS, especially in context of routine operations. We then decided to monitor the pressure for over 100 injections of 2-fold diluted urine samples, and the pressure for both the analytical column and the loading cartridge. So over the course of all these injections, we did not see an increase in pressure for either of these columns. We later decided to increase the dilution factor to 16, but this was due to retention time instabilities that were observed when employing 2-fold dilution for certain urinary matrices. So then in summary, we validated a confirmation method for 50 doping relevant small peptide hormones by employing nano-LCMS. It was validated according to the criteria as imposed by the World Anti-Doping Agency. The assay employs direct urine injection in combination with an online filter in order to minimize offline sample preparation, leading to a sensitive and robust method for the confirmation of small peptides, which could possibly also be applied to other substances or matrices in the future, which is something to be explored. And then, of course, I would like to thank all of you for listening into my poster presentation.